Hi, everyone. So today we are going to cover sequences. So these are not covered formally in the textbook, but they are important in mathematics. And so we're going to cover them through these supplemental notes. So since they are not in the textbook, there was not anything for you to read before you came and watched this video today. So by definition, a sequence is an ordered arrangement of numbers, figures, or letters. So the most common type of sequences we see in math are the ones with numbers. So we can have 1, 2, 3, 4, 5, 6, 7, and so on, right? So that is a sequence of numbers that's just the whole numbers, the counting numbers, go increasing from 1. So that's numbers. So we can also have a sequence of figures. We can have a circle, and then a square, then a triangle, another square, a star, a heart, another triangle, and so on. So this would be an example of a sequence of figures. So a sequence really can be an ordered list. I really don't like that word, arrangement. So we can replace it with an ordered list of anything, really. It can be super abstract. You can have a list of cows and pigs. Anything you want can be a sequence. So for our first example, we are going to look at a sequence of letters. So we have this sequence O, T, T, F, F, S, S, E. And we are tasked with finding the next 3 terms in the sequence. So at first glance, the sequence looks like, well, you start with O, then you have 2 T's, 2 F's, 2 S's. So we can guess that our next letter would be E. So we can guess that the next term is E. Okay, so if we guess that the next term is E, well, we're not just finding the next term, we're finding the next 3 terms. So if we guess that the next term is E, then what? So yeah, even though at first glance it seems like we're having doubles of letters, well, if the next term is E, we don't really know what's next. So this is where the definition of sequence comes in handy, right? Because this is an ordered list. And so everything in a sequence has an order. We have the first term, the second term, the third term, the fourth term, the fifth term, the sixth term, the seventh term, the eighth term. So every term in our sequence has a position corresponding to a number. So I'm going to say that again. We have the first term, the second term, the third term, the fourth, fifth, sixth, seventh, and eighth. So do you hear a pattern there? We have first, second, third, fourth, fifth, sixth, seventh, and eighth, and so on. So we have something in position 1, 2, 3, 4, 5, 6, 7, and 8. Do you see where I'm going with this? So if we write out those numbers in words, we have 1, something in position 1, position 2, position 3, position 4, 5, 6, 7, 8, and so on. So at this point, we can see O, T, T, F, F, S, S, E. And look, those are exactly the terms in our sequence up here. So just by thinking about the definition of a sequence as having an order and a position corresponding to each thing in the list, we can figure out the next three terms. So that means that the next three terms, so we have that the next three terms are the first letters of 9, 10, and 11. So this is our answer. Okay, so a really important part of this definition of sequence is the ordering of the terms. It's an ordered list. It's not just a list. It has an order, and everything in the sequence has a corresponding position. So when we keep going, we're mostly going to deal with sequence of numbers, as I'm sure you can expect from a math class. So we're going to deal with sequences of numbers that have certain patterns. So in general, we're going to be able to write this pattern as an algebraic expression where our variable is n, corresponding to the nth term of the sequence, that term in the nth position. Okay, so that was your introduction to what a sequence is, and that's all for this video.